right, so let's chat about the homework. So there was kind of two parts to it, right? And I think you'll like what we're going to do today as well. But the first thing I want to do is, it was page 146. But I gave you 146 just to do 6 of them, right? So it was the page before was what we had actually done previously, right? So let's go to page 144, please. We'll just take a look at page 144. And, you know, I think we did 1, 2, 3, and 8. I think that's what we had done. Is that true? Okay, so let's talk about them a little bit more. Let's talk about those a little bit more. Is there anything on page 144 up through number 12 that you're not sure about? Or it seems silly? Go ahead.
Oh, sorry, I couldn't see your face. Number 9.
9. Want me to work it?
Yes, please.
Would you do me a favor? Would
Yes.
you read for me what the first equation is?
Yes, it is 5x plus 2y
Easy.
equals 9.
It's 9, okay.
And then the second one is x plus y equals -3.
Did I write it all correctly?
Yes, you did.
Giddy up. All right, I didn't. Oh.
Why are you trying to pull that?
All right. I see a couple earbuds in. They need to come back out, please. So, very first question. Hey. If you're a little. Yep. So, first question. We're not graphing it. We want to use substitution. So, are either of the equations solved for x equals or y equals right this moment? No. Could I solve the second equation for either x or y by just subtracting it from one side? Cool? So, let's see. Let's just subtract y from both sides. So some of you are like, why did you choose that one? I picked. So that cancels that. So I get x is equal to -3 minus y. Simple enough so far? Have I done anything to start figuring out x or y right now? No. So I'm going to take this top equation here, and I'm going to take this equation here, because that bottom equation was modified from one of our originals. And I know that x is equal to now the relationship -3 minus y. Yeah? What do you think I should do with that -3 minus y in the first equation? Go ahead. Plug it in for x. Okay? So I'm going to take this right here, and because that's what x is equal to, I'm going to put it in there. So I'm just going to kind of draw it. I have 5. I'm going to do parentheses plus 2y equals 9. This had been an x, but now I'm going to take that and plug it into it. Talk to me.
Couldn't you just so if x plus y equals 3, couldn't you do the cover-up method? So x equals -3 and y equals -3. Am I right?
That would be for if you were to graph it, absolutely.
Oh.
But so if you're graphing it, you're finding the x and y intercept by doing that, and I love you for thinking that, but you're not figuring out where it's crossing the other line. You're just finding where it's crossing the x and y axis.
Well, yeah, but then you would put -3 into 5 and then -2 into
Oh, I see what you're
2
doing.
and then equals 9.
Okay, so let's just kind of do a little thing. So you said -3, -3. So that would be that equation. The other equation might look like this, where this would be that's our shared point. Where these 2 points happen to exist only on the blue, they don't exist on the red top equation.
So what I was saying doesn't work?
It would not work, no. Because where it crosses the x or y axis is not necessarily where the 2 lines cross each other. It just happens to be where it crosses the x and y axis.
Okay.
All right. So we're down here. I'm going to distribute 5 here and here. So 5 times -3 is -15. Minus 5y plus 2y equals 9. Is that right? Do I have any like terms on the left side of the red? Yep. the y value. So I have negative 5y and positive 2y. If I combine those together, I get negative 3y. And then I'm going to have to do what? I want to get y by itself, so what would be the next step? Add what? Yeah, add 15 to both sides. So I'm going to get negative 3y. I'm going to add 15, so I add it here. You cancel that, add it here. That gives me 24. And so then what does y have to equal? So our y value has to be negative 8. Agree? Okay, so now we have a y value, which is fantastic. We're looking for, so that's the y value. We need to now find the x value. So I need to find one of my equations that has both x and y in it, even if I modified it, right? Even if I modified it. So let's show where this could go. This here, I could put it here. I could put it here, or I could put it here. So there's 3 different spots I think it would be a valuable place to put it. So just, look at the very top equation. Does that look like if I plug it there, I have a little bit more work to do than say if I were to plug it where on the very bottom, x equals negative 3y minus y. Does that make sense how I just said that? So it gets you the same answer. It's just one of them would require a lot more work to get to the answer. So I'm going to take that negative 8, and I'm going to just plug it in right here. So I'm going to modify here. X equals negative 3 minus negative 8. Hey, negative is positive, so x equals negative 3 plus 8. If I see something that costs $3 and I have $8 in my pocket, and I buy that thing for $3, do I still have money left? Yeah, how much do I have left? 5. So 5, 8 is where our lines would cross each other, not negative 0, negative 3, and negative 3, 0.
Which is weird because like I got the same thing.
Did you get that answer?
On the bottom.
On the bottom.
Like the negative 15 minus 5y plus 2y equals 9.
Okay. So.
But I erased it. So I don't know.
Okay. Perfect. Other questions that we might have come across on page 144. Yeah. 4 and 7. Cool. Yeah.
Number 10.
Okay, we'll get there in a second. Number 4 and number 7. Alright, number 4, I have x minus y is equal to negative 3, 3y plus 4x is negative 5. And then number 7 is x minus y equals negative 3. Oh, shoot. Flush. Thank you. Okay. Very first question. You want to solve where these are crossing each other as a point. Okay, so we need to find an x value and a y value, which would yield our point. Do either of the equations right now, are either of the equations solved for x equals or y equals? So everyone feels comfortable with that? Yes, ma'am?
The top equation is x equals 3y minus 27.
Holy cow, did I brutalize that one? Thank you. I'm writing the wrong things down. And thank you so much. So, we're doing 4 and 7, so we're doing 4 first. Of course, I made part of number 7 go with number 4, which that goofs things up, and that gets us different answers. All right, so item 1. So take a look back up here. Are one of the equations solved for x equals or y equals? On this one, yes. Okay, so I had to modify this a little bit. So I'm going to take this part right here, that part right there. That's what x is equal to, and I'm going to plot it right here. Okay, it's going to substitute in. Agree? All right, so I get 2y plus 5 equals 35. This had been an x. Yes?
Yep.
What's going to go there now? 3y minus 27. Awesome. Okay? I should distribute over the parentheses, so I have 2y plus 15y minus 5 times 27. 5 times 5, 135. Is that right? Did I do that right?
Yeah.
Okay, just want to make sure my math is good. I do have like terms. These are my like terms right here, so I'm going to combine those. Add 135 to both sides. That comes out to like 170. So y is equal to 10. So part of my answer, my y value is 10. My x value I don't know yet. Okay, if I wanted to figure out my x value, where should I plug 10 in? To the first equation that's surrounded by pink, or the second equation? First one. Because what value am I looking for? X. This one's saying, hey, x happens to be equal to this. If you know the y, you're going to know what x is. Oh, sweet. All right, so I'm going to take this 10. I'm going to plug it right there. So let's bring this down here. I get x is equal to 3 parentheses minus 27. Make that a 10. So that's now 30. Hey, where'd that 10 come from? Oh, right there. So this comes with an answer of 3, 10. Cool. Number 7 we already have up there, so let's take number 7. All right, so first question. Are either my problems solved for x or y? The answer is no, but I think you feel comfortable making the top equation this. What did I do to get there? I added y to both sides. So then I can find that x is equal to this clump of stuff, right? What should I do with y minus 3? Yeah, I'm going to take this, and it's going to go right in for x. It doesn't go in for 4x. It goes in for the x that happens to be attached to the 4 by multiplication. All right, so I get 3y plus 4. There had been an x right here, and that's equal to 5. There had been an x here, but I know now that I'm going to plug y minus 3 in for it. Okay? What should I do with 4? Distribute over the parentheses. So 3y plus 4y minus 12 is equal to negative 5. Okay? Like terms, 3y and 4y is 7y. 7y minus 12 equals negative 5. Add 12 to both sides, so I get 7y equals 7. So what is y equal to? 1. Good. So I keep solving these for y, which is fine. So I have an x and a y value. Okay? Where would it make sense to plug that y value in? Into the y. So let me show you where this could go. Okay? This right here can go here. It can go here. Or it can go here. They will all get you the exact same answer, but what value am I looking for? X. Are one of those equations up there solved for x right now? Yeah, so where should I plug it? What color is it? And once you're colorblind, then you see that's the same. What color? Green. Yep. So I'm going to plug this right here. So that's going to give me, and we'll just bring this down here so we can write it. X equals blank minus 3. That had been a y right there. Now it's going to be a 1. 1 minus 3 is negative 2. And this is my answer. Yes. As soon as I flip the page, yes. All right. Are we good with the 1 through 9?
Yep.
Feeling comfortable? Good. All right, so number 10, 11, and 12. So this is as simple as you need to make 10, 11, 12. Write a system that has one equation. do I know those will cross each other? The what? Kinda.
They don't have the same slope.
They don't have the same slope. The first equation has a slope of 3. The second equation has a slope of 4. They are different slopes. They have to cross each other. Does that make sense? Is that the only right answer to write? No. Any. So all you have to realize is if I write that with two different slopes means they have to cross each other. How would I write something with no solutions? Well, if there's no solutions, we know the slope has to be positive, or the same, right?
Yeah.
And I have to have a different y-intercept. So 3 and 3 are my slopes. I have different y-intercepts. Those are parallel lines. I don't have any solutions with parallel lines. How do I write one with infinitely many lines? Infinitely many solutions. So let's take that and watch this. Are those the same equation? They are. The bottom equation, I just subtracted 3x to bring it over. So that's infinite. So one solution here. No solution here. An infinite solution here. Cool? We're on the back side. Looks like we got some word problems. Or wait, which ones you got? 16, 17, what? Who, where? So 13, 14, 15, are we okay to have graphed those?
Yep.
Anybody need to see any graphing problems? So we know if they cross each other, where they cross, that point they cross is our solution. They happen to be parallel to each other, they don't have a solution, and if it happens to be the exact same line that lies on top of itself, then you can go with infinite solutions. So 16, 17, you want to see those?
Yes, please.
Number 16. Oh, it's a story problem. I can't wait to find out what happens.
I thought it was really hard.
The length of a rectangle is 4 more than twice the width. The perimeter of the rectangle is 44 centimeters. P equals 2W plus 2L, so that's the perimeter. Let W, the width of the rectangle. What is the length in terms of W? Find the dimensions of the rectangle using a system of equations. Okay. So, word problem. Let's draw what we might have. So that appears to be a rectangle, and you've been indoctrinated to know that the length is usually longer than the width. You'll find out next year in geometry that it doesn't really matter. But let's just stick with what we know so far. So we have a rectangle, we know we have a length, we have a width. We know that our perimeter equation is 2 length plus 2W. We also know that the area of a rectangle is length times width. I don't know if we would need that. But those are just kind of some go-tos that we could know. The length of the rectangle is 4 more than twice the width. So the length, so if the width is W, then the length has to be, what did it say about the length? 4 more than twice?
Yes.
Than twice the width. So our length is 4 more than twice the width. So we're going to keep W as our width. We know that the length is going to be 4 plus 2W because the length happens to be 4. I add to that twice the width. Okay? What else did they tell us? Oh, we know the perimeter. They told us the perimeter is 44 centimeters. Agree? All right. So, this right here is the length in terms of width. Okay? Which means I can take this right here and say L is equal to 4 plus 2W. See how I did that? From there, I can go ahead and start plugging things in. So I know that L happens to be equal to this. W we're going to keep as W. So let's take this equation right here and see if we can figure it out. Okay? So I know that 2 blank plus 2W equals 44. This had been an L. What did I just find L to be equal to? 4 plus 2W, right? So that, let's write this in. parentheses. Okay, let's distribute. So you get 8 plus 4w plus 2w equals 44. Agree? Like terms? If I add 4w and 2w, I get 6w. If I subtract 8 from both sides, so I now find I have a width of 6. So my width is 6. How do I find my length? Yeah, you do.
You plug in.
Where am I going to plug 6 in? Where? What's the length equal to? 4 plus 2w. Do I know a w? So I'm going to plug 6 in right there. So 4 plus 2w, or 4 plus 6 times, and that's going to give me, that's 12, this is 16. So I have a length of 12 and a width of 6. And I guess we should mark that this is 6 centimeters and this is 16 centimeters. And how do I know centimeters? So they told us that the perimeter was 44 centimeters. Okay, and then number 17 says for the following problem, write an equation that represents the sum of the angle measures of a triangle. If I add up the interior angles of any triangle, what do they have to add up to? 180. That's just something that you learned someplace. So whatever my triangle is, and what does this little square mean down here?
Ooh, it's a right angle.
It's a right angle. How big is a right angle?
90 degrees.
90 degrees. So we know that that's 90 degrees because some book somewhere told us. We have this as x. We have this as y. They happen to tell us, I don't know what this means. They happen to tell us this relationship takes place. That takes place. I don't know where that came from. I think it was just given information to us. Okay? Now let me ask you this. You told me that if I add up all 3 angles of a triangle, I get what? 180. So if I add x, and I add y, and I add the 90, I get 180. So could I say this? And if so, how did I get there? If x plus y plus 90 equals 180, what reason does x plus y equal 90? What happened between the 2 blue equations up there? So notice on the top right, I have x plus y plus 90. Good, I subtracted 90. Okay? So, I'm going to use this equation here, because I modified that one, and this was given to us as an equation. Okay? Are either of those solved for x or y? No. Could I solve one? Yeah, so maybe let's modify this one to become this. What did I do to get there from that equation? I subtracted y. Good. This right here is going to go where? Into the x right here. Okay, because we know x equals that. So that gives me 90 minus y plus 2 equals 3y. Right? This 90 minus y was that x value. I plug it in, the plus 2 comes along to the right. Combine like terms, so 90 and 2 added together, 92 minus y equals 3y. If I add y to both sides, I get 92 equals 4y. If I divide by 4, y equals 23. So that means this angle happens to be 23 degrees. What do all 3 angles add up to of any triangles? 180. So I have 90 plus 23. So this has to be 67. Because 67 plus 23 is 90. 90 added to this 90 is 180. Life good? How'd you feel about those 6 problems on page 146? Did any of them get goofy on you? Yeah. 6? 7, 8, 9. You didn't have to do 7, 8, 9, but we'll do it.
You did it?
I just wanted you to one. I was 6 on one.
Yeah, I
Okay.
did the whole thing.
Sammy, which one do you want to see on the first page? 6? Okay. Yeah, you only have to do 1 through 6 on page 146. But,
Can you do one?
yeah. Let me start with number 6. We'll work our way backwards. Is that all right? Okay. First item on the agenda is one of the equations, x equals or y equals. Cool. So we have something to plug in right away. Do you agree? So I'm going to take this and plug it into what?
What?
I'll plug it into the y on the first equation. So let's bring this down. I have 7x minus 8 equals 112. This was a y value. What am I going there? What goes here?
Negative 2x plus 9.
Negative 2x plus 9. Good. All right. Be careful. Make sure you distribute negative 8 to both. So I have 7x. Negative 8 times negative 2x is positive 16x. Negative 8 times 9 is negative 72 equals 112. Did I check right okay on that? Yeah. All right. Kind of like terms, 16 and 7x being added together would get me 23x minus 72 equals 112. Let's add 72. 72, sorry. So 23x is equal to 4, 8, 184. Divide each side by 23. Anyone got a calculator? I can't do that in my head. 184 divided by 23.
What is it?
184. It comes out to 8 exactly, divided by 23. Thank you. All right, so we have our x value being 8. Okay, I can take this x value and plug it into this x value. I get y equals negative 2 plus 9. There had been an x there. I'm plugging an 8 in. That gives me y equals negative 7. Here's my solution. Sweet. Let's hold off on the rest on 146. Do me a favor, will you go to page 148? 148. This is part of your homework, but let's see if we can kind of work through it together. Okay, so I'm on page 148. This is off of page 148, which will eventually become your homework. Okay? But problem number 1, I have, yeah.
Where are we skipping 146? 147.
It'll be there. We looked at one of the problems on 146. Part of that was your homework. All right, so page 148. So just like any math class, if there's 2 ways to solve something, there must be a 3rd way. Okay. I think you might like this way. This way is a fun little puzzle. Okay? You ready? We have 2 linear equations. They should cross each other, yes? Okay? Or they might be parallel, but they might be the same. Now, how we had been working this with substitution is we tried to solve one of the equations for x or y and plug it into the other. Agree? So let's add a curveball to this. There's not really a curve, but I think it'll be like kind of realign a few things in the brain for some of you. Do I have an x value or a y value between the two equations that are exact opposites? Yeah, which letter? The y. I have a negative y and I have a positive y. They are exact opposites of each other. Would you agree? So if I have exact opposites of each other, watch what I'll do. Watch this. Ready? Pencils down. Just watch. 3x plus 2x, 5x. Those cancel. Equals 20. X equals 4. Oh! Have I solved the whole problem yet? No, what do I need to find still? Y. So I have 4 as my x. What should I do with that 4 to solve for my y? Plug it in. Pick one of the equations. Which one you want to pick? Doesn't matter. Okay, I'll pick this one. I'm going to plug it in right there. So I have 2, that was an x, plus y equals 8. What's going to go right here? 2 times 4 is 8. Subtract 8 from both sides. But it became 0. Good. That's where these lines cross. Oh, wow. Wait a minute. Can I go to number 2? Does anybody need more time to look at that? So this is called elimination. It's called the addition method. This is really cool math because this is where some real higher level math can stem from, this type of, it's called the elimination or addition method. So problem number 2, negative 4x plus 3y equals 11. 4x minus y equals negative 9. I want you to try this on your own right now. I want you just to add the two equations together right now and see what happens. See if you can figure it out. This is problem number 2 on page 148. Yeah. You got it. Was the first step real simple for you? It was real nice because when I added the two equations together, one of the letters completely dropped out because they were exact opposites of each other. Agree? And then what I did is I plugged. Did everyone get to at least y equals 1? And then what did I do with that y equals 1? Well, I have two equations originally that have both x and y in it. I had to pick one of them and replace the y with a 1. Can I move forward to the next one? All right, before you start working this one out, let's talk real quick. Can I add the two equations together right now and have one of the letters fall out? Does everyone see how that's different? If I add these two equations together right now, I wind up with 6x minus 10y equals 32. And I now have an x and a y value to deal with later with bigger numbers. Okay? Does that make sense so far? So, yes?
I think I know what to do.
What do you got?
Do you multiply the top equation by -5?
Why is that?
Because if you have, so you have to cancel, if you're canceling out one of the letters for y is like, they already have numbers on the y, so x is the only one that doesn't have a number on it, so you have to multiply it by -5 for it to cancel out.
What an incredible mind. You just saw it. Okay, so if you look at the top equation, we have 1x minus 4y. Okay, so the rules on this, if you do something to one equation, you don't have to necessarily do something to the other equation. You can do something to both equations. In this case, it looks like if I multiply the entire top equation by -5, if I go here with a -5, here with a -5, here with a -5, let me modify this. I get -5x plus 20y equals negative, what's 5 times 24? Anyone know?
5 times 24. 2,400.
Oh, yeah. 120?
Yeah.
Is that right? I don't think I have to do anything to this equation, but I'll just bring it over so we can line them up. All right, quick question. If I add those two green equations together, do I have opposite x values?
Yeah.
Everyone see that? If I add these two equations together, that cancels that. 20 minus 6 is 14, and we got a y equals negative 128, right? Divide each side by 14. It's negative, I know that. What's 128 divided by 14?
9.142.
Was that 9.142? Really? 128 divided by 14. What am I dividing? Negative 128 by what? Oh, second quit. Negative 128 divided by 14. Oh my goodness, get out of here. I don't want that. Get here. There we go. Clear. Negative, this one should work. Negative 128 divided by what?
14.
Holy moly! Negative 9.14. Let's see if this works. Math, fraction, enter. Ooh, okay. Negative 64 over 7 is the answer there. Oh, you guys didn't know the calculators had that kind of cool feature, huh?
What did you just press?
Math, fraction, enter. It'll take any decimal that's a terminating decimal and make it back into a fraction. Okay, so negative 64 over 7. Okay, negative 64 over 7. Yay. Now y'all might not like me too much. Negative 64 over 7 is my y. Okay, oh shnikes. I have to figure out which place to plug this in. And I don't know if there's a nicer way to do it. Let's bring this down. I'll give it the same answer. So I get 5x minus 6 equals 8. Yuck! I'm going to plug negative 64 over 7 in right there. Oh my goodness. But I have a calculator, so I'm going to take...
You could be on the test.
Well, I don't know. Times, I'm going to multiply those together. So negative 6 times negative 64 over 7. So times, oops. Let me start. Times negative 6. Times, I forgot. Negative 6. Negative 384 over 7. Ooh! Positive 384 over 7. Oh my goodness. Oh wait, that's not the answer. I'm sorry. Okay, so this is going to be 8 minus 384 over 7. Oh my goodness. 8 minus 384 over 7. 8 minus 384 over 7. Math, fraction, enter. Negative 328 over 7. Oh my goodness, we just got ugly. Negative 328. What's that? Negative 328 over 7. You guys are, if I divide both sides, ew. Guys and girls, that is as ugly can be. Could you imagine trying to graph that and find where they intersect?
Yes, I have a question.
Yes, sir.
So you know on page 148, how you did the averaging stuff? You do that on 146 because
All right.
you just showed us that just to do it.
Nope, that's it. All right, so guys and girls, on Monday, I need 144, 145. That needs to be complete. I need page 146, 147 to be complete. These would have been what we have worked a whole bunch on, yes? And then I need you to have on page 148, so I'm going to collect these. This will be collected on Monday. But then I need 1 through 9 done on page 148, please. And I want you all to have a great weekend. Take care of one another.
All right, Mr. Thank you.
Yep.
Oh boy, that would have worked out. Oh, thanks for seeing that.